Okay, today I'm doing a short video on using a boring head on a Bridgeport mill. This particular model is a very old version. It's got a serial number of 1048 or JBR 1048, and when I investigated the age of this mill, its history goes back to the Second World War when it was manufactured, but it's in very good condition. I bought this from an engineering company where the gentleman retired at the age of 83, and he'd had this machine most of his life, but it's in exceptional condition. It's fitted with a DRO only in X and Y, so the Z direction is controlled either manually with the handle here, or if this is flipped across, you can use the wheel. This also has an automatic feed for getting a very smooth cut on the boring head when you're boring. This is an LPAS boring head. It's an automatic head, although we're going to be using it in manual mode. On the scale here, this is scaled in it's a metric scale, and each division is 0.01 millimeters in diameter. And the job today is we're going to be boring out some tubes I need to bore down a certain depth at one diameter and a shallower depth at a slightly larger diameter. The two diameters are 35 millimeters for the larger size and 32 millimeters for the smaller size. Now you can see that I've set this up in the chuck using a single V block to control the position in the X direction, and Y is controlled by the back face of the vise. So when I initially set this up, I used a wobbler on the faces to get a position of 0. On the other face, when I picked up on the wobbler on the other face, I then used the DRA in center 0 mode to get a dead center on X, and then I repeated the same thing for Y. Front edge 0'd, go to pick up on the back edge and go for a center. So you can see at the moment that's set to 0, 0, which is dead center. Now after I'd done that exercise, I then set up a fixed end stop for my V block, so that when I'm repeating this for multiple tubes, because I have to do 16 of these, I can get the position quickly each time I release the chuck to put the new work in. Okay, now this boring head has 3 positions to put the boring bar in. You can go in on underneath here in the center position. You've got 2 outers here, but they're effectively the same offset, and also you can put a boring bar in at 90 degrees for very large holes. Now you can see here I've used a very stout boring bar. The thicker you can get the boring bar, the more stiff the whole system is and prevents any chatter vibration. Now for my first cut, I've set this up for my smaller diameter of 32 millimeters, and I'm on a setting here of 190, and by adjusting this outer ring, it effectively moves the boring bar in and out off the center line. So 190 is the setting for my smaller diameter, and up here I've set the depth that it's going to cut for this one and I'm using a crude scale here. It's just a ruler effectively bolted to it, so I don't have a ZDRO readout, but I've measured that distance for my depth between this head and the variable adjuster here, so you can get this gap quite precise. If you're doing a small depth, I often put a drill in between here and adjust this till it touches the shank of the drill. So that on this particular one is set to 8.4 millimeters in the Z direction. Okay, cutting speed. Now I'm machining aluminium here with this boring head, and I don't really need to go at really high speed. I know for aluminium cutting you can run at high speeds, but I like to go at a nice steady speed, and I've worked out that about 300 RPM is about ideal for these radiuses that I'm cutting. So on this particular machine we were on the third belt setting from the top, which is the third highest speed, and you can see we've got the back gear here is in the in position. This is over to this front position, so it's in. So we're going on slow speed operation, and we have the top lever to the side, so it's running slow, and I've calibrated to get 300 RPM. I've got a variable three-phase motor here, variable frequency, and I'm on setting 8, and setting 8 is around about 40 Hertz, and that gives me an actual rotation head speed of 300 RPM. The little white tape here is actually my indicator for putting a tacho, so if I want to measure the speed any time I'll put a tacho on there. But I've got a calibrated set of curves that I use, so I know for my speed setting down here, I know what to adjust that to for any particular belt position. For high and low speed, back gear in or back gear out, I can get quite an accurate speed. I don't like changing belts, so I tend to use the variable speed control on adjustment of frequency as much as I can. It's much faster. Okay, now for cutting. I've set my depth up, as I said earlier in the video, by adjusting the vernier here to get the correct depth for the smaller diameter or smaller radius cut that I'm going to be doing. The boring head has been set up, as I said earlier, and the speed is now adjusted, so I just get the boring head off the surface. You see this one's only going to take quite a fine cut because I'm just easing out the inner bore of this tube. So we'll start the mill up. As you can see, this is in automatic Z mode, driving down, because that is pushed in, and all I need to do to engage that is to pull this lever out. So if I pull that lever out, you can now see that we'll start to pick up and start winding the head down into the tube. Gradually coming down, and we're starting to take a cut now. Put some lights on. Prefer to run in automatic mode because you get a nice smooth cut without too many spirals showing on the inside face. When this stop comes down to my vernier, it will take off the drive, and I have to finish off by hand with the wheel to get to the bottom. As you can see, it's closed the gap up. Okay, that's taken off. I'll just finish off by going right to the bottom of the slot and until that is in hard contact with my adjuster. Okay, so I can bring that back out, stop the mill. Okay, get rid of the swarf. Now I'm now going to set up for the other dimension. So I'll swing the head round. I've got to come out 0.3 of a mil. So I'll undo the adjuster here, spin this round one complete rotation, which is 0.2 of a mil. And then another half a turn, so it's 0.3 of a mil on diameter. Okay, that's dead on 90. Tighten that up so it can't move while it's rotating. Now I've got to readjust my depth. Now I've worked out for my second cut this has to be set up to 7.6 centimeters on the top. So I just line that up by eye. And then if I offer that down, you can see that's the sort of depth I'm cutting. And down here, it's going to take this out in one cut, so 0.3 mil I'm effectively taking off on diameter, or 1.5 millimeters on radius. Okay, so we take it slightly above again, start the mill up, because with back gear you have to put it in reverse to get the right clockwise rotation. Put the drive on and you should start driving down, taking that cut. To the bottom and just take it down to the end stop. Just hit the end there so it's not cutting any deeper. So I can withdraw that tool, stop the mill. Okay, take the swarf out. Right, because there's a slight lip there, I've got to adjust for the next tube. I've got to go to the inner bore again, so I might as well set that back up. So let's spin that round, take off now 0.3, so that's all the way around one revolution to 90 and half a revolution to 190. I'll go beyond and then come back to take any slight backlash out. Block that off, readjust my depth for the deeper one, which is 8.4 centimeters. That's 8.4 there. Okay, so I just want to run this tool down to take any slight lip that might have occurred at that transition. I'll start this up, and I won't mess around going in slowly. I'll take this down by hand. It's just taken that off. Stop that. I can now remove the finished work. Okay, so there you go. Much faster than doing on the lathe.